Now, on to our main topic: Three Eye Atlas, interstellar enigma, comet, cataclysm, or cosmic deception. To commence, we must return to the origins, for every compelling narrative requires a clear foundation. Envision the scene. It is early July 1st, 2025, in the arid Atacama Desert of Chile, where a telescope array known as ATLAS, the Asteroid Terrestrial Impact Last Alert System, operates. This system comprises telescopes dedicated to identifying potential threats from space, such as asteroids that could approach Earth. But why do we even have ATLAS in the first place? Developed by the University of Hawaii and funded by NASA, Atlas was specifically designed as an early warning network to spot smaller near-Earth objects, those pesky rocks or ice chunks that might slam into our planet with little notice. Unlike larger surveys that hunt for mile-wide monsters years in advance, Atlas focuses on the sneaky ones, the house-sized threats that could zip in from the shadows just days or weeks before impact. It's like having a cosmic smoke detector, scanning the skies every clear night to give us a fighting chance to prepare or deflect. Without systems like this, we'd be caught flat-footed, much like our ancestors who had no clue when the sky might fall. On that fateful evening in the desert, Atlas detects a faint moving point of light in the sky. The object registers at an apparent magnitude of 18, rendering it nearly invisible without advanced equipment. The observers provisionally designated A11PL3Z and transmit the data to the Minor Planet Center, the international authority for cataloging solar system bodies. The investigation does not end there. Researchers consult archived images from additional Atlas installations and from the Zwicky Transient facility at Caltech. These records reveal that the initial detection occurred on June 14th. This discovery affords the astronomical community valuable additional time, several weeks, to mobilize resources and direct instruments towards the object. The urgency stems from its remarkable velocity, approximately 61 kilometers per second, equivalent to more than 137,000 miles per hour relative to the sun. Such speed exceeds that of any body gravitationally bound to our solar system. It's a red flag waving in the cosmic wind, screaming that this isn't some local asteroid looping lazily around the sun. It's an outsider crashing the party from the interstellar highway. Astronomers promptly compute its trajectory, determining it follows a hyperbolic orbit. To clarify, most solar system objects, including planets, asteroids, trace elliptical paths around the sun, akin to circuits on a closed track. A hyperbolic orbit, by contrast, resembles a broad arc that permits a transient passage before departing indefinitely. The critical metric, eccentricity, measures 3.1396 for this object. Values exceeding 1 indicate it's unbound and merely traversing our system. This isn't a visitor planning to stay. It's a cosmic tourist with a one-way ticket in and out, slingshotting past the sun before vanishing back into the void. By mid-July, formal designation arrives, 3I Atlas, with the 3I signifying the third verified interstellar interloper, an atlas honoring its discoverers. It also receives the comet classification C2025 N1 Atlas, owing to the early indications of cometary activity, such as a diffuse halo and nascent tail. A research team from Michigan State University publishes an initial analysis on July 11th, employing imagery from the Southern Astrophysical Research Telescope. They note its reddish hue and irregular brightness distribution, suggesting uneven dust emission. The schedule proves advantageous. The object attains perihelion, its nearest solar approach, on October 29th at 1.356 astronomical units, positioning it slightly inward from Mars's orbit. Thus, we can enjoy months to observe it before its display intensifies. This window is a gift, allowing us not just snapshots, but a full symphony of data collection, from ground bases, gazes, to orbital eyes in the sky. NASA commits fully to the effort. The Hubble Space Telescope captures exquisite images from orbit. The James Webb Space Telescope analyzes its internal structure, and Martian rovers prepare to photograph it during its proximity. Terrestrial observatories, including Gemini South in Chile and the Gran Telescopio Canarias, contribute observations. It resembles a worldwide astronomical symposium centered on a single phenomenon. Given that humanity has documented only 3 interstellar objects to date, such enthusiasm is entirely warranted. These rare flybys are like winning the lottery of the stars, opportunities to peer into other solar systems without leaving home. Beyond professionals, public engagement surges. On the platform X, discussions evoke memories of ʻOumuamua, with queries like, could this herald genuine first contact? Accompanied by humorous illustrations. As of October 4th, amateur astronomers with suitable telescopes can still view it. By perihelion, its magnitude reaches 10, potentially visible to the unaided eye in pristine skies. Should you plan an evening stargazing soon, consider acknowledging this transient guest. Grab a blanket, find a dark spot away from the city lights. That's not so easy these days. And let your eyes adjust. It's moments like these that remind us how connected we are to the greater cosmos. Let us consider its provenience and trajectory, as these elements contribute significantly to its allure. Interstellar objects are expelled from their native systems through substantial gravitational interactions, perhaps propelled by massive planets or stellar encounters. Subsequently, they navigate the galaxy for billions of years until ensnared by our sun's gravity for a fleeting sojourn. Estimates suggest billions populate the Milky Way, yet detecting one within our solar confines is fortuitous, facilitated by vigilant surveys like Atlas. These drifters aren't just curiosities, they're windows into the universe's recycling bin, carrying frozen snapshots of alien chemistry and formation processes that could rewrite our understanding of how life might spark elsewhere. For 3I Atlas, its path is a perfect example of this kind of quick zip through our solar system. It follows a hyperbolic shape, like a wide open curve that doesn't loop around the sun, but just swings by and keeps going. One key number for its orbit, called the semi-major axis, is negative 0.26392 astronomical units. That's a measure of the distance based on how far Earth is from the sun. The negative value and sign means it's not trapped here. It's free to escape back into deep space. The tilt of its path is 175.11 degrees compared to the flat plane where our planets mostly travel. So it's moving backwards, and that's called a retrograde from how things usually go around the sun. But it's only dipping about 5 degrees below that plane. And the speed it had when it entered from outside of our solar system, a whopping 58 kilometers per second. That's super fast, like racing across the US in under a minute. Retrospectively plotting its course originates from the constellation Lyra, proximate to Vega, though not precisely. The actual genesis dates to 7.6 to 14 billion years past, likely within the Milky Way's thick disk predating our solar system. Its ingress at 5.5 astronomical units from the sun beyond Jupiter and accelerates under solar attraction. Perihelion occurs on October 29th at around midnight, Universal Time. Thereafter, it departs, approaching Mars on October 3rd, Venus on November 3rd, Earth on December 19th, and Jupiter. The latter proximity inspires concepts for pursuit missions, meaning we can go there perhaps. But let's pause here and talk about what could happen if a comet like this, or any sizable one, didn't miss us so gracefully. Imagine 3IA Atlas, instead of its harmless flyby, was aimed straight at Earth. A comet impact isn't just a bang, it's a planetary reset button. Depending on its size, say a kilometer-wide chunk like this one, the immediate blast would carve a crater miles wide, unleashing shockwaves that flatten forests, trigger mega earthquakes rippling across continents, and spawn tsunamis towering hundreds of feet high, drowning coastlines in minutes. The airburst alone could ignite global firestorms, while the dust and vaporized rock lofted into the atmosphere would block sunlight for months or possibly years, plunging the world into a nuclear winter-like chill. Crops fail, oceans acidify, food chains collapse, billions could starve in the aftermath. We've seen echoes of this horror in the Earth's past, like 66 million years ago, when a similar size asteroid, about 10 to 15 kilometers across, slammed into the shallow sea of what now is the Gulf of Mexico, forming the Chicxulub crater buried under the Yucatan Peninsula. That cataclysm vaporized seabed rock, hurled debris worldwide, ignited wildfires across the globe, while sulfuric aerosols from the impact shrouded the planet in darkness for years. The result? A mass extinction that wiped out 75% of Earth's species, including the mighty non-avian dinosaurs, paving the way for mammals and eventually us to rise. It's a sobering reminder. Space is beautiful, but it's also a shooting gallery, and tools like Atlas are our best defense against the next unwelcome visitor. Harvard astronomer Avi Loeb, renowned for posting ʻOumuamua as potential artificial construct, observes that the trajectory aligns precisely with our planetary plane. He estimates natural probability at 1%, implying possible guidance. Nonetheless, simulations indicate such configurations arise frequently given galactic dynamics. No anomalous accelerations from outgassing appear thus far, contrasting Oumuamua's, though ongoing data may alter this. Regarding formation, evidence suggests cosmic noon, 10 billion year old epoch of prolific stellar birth within a metal deficient protoplanetary disk. It contains extrasolar materials invaluable to astrobiology. Hey, what are your impressions thus far? A fortuitous voyager or an improbable precise itinerary? Share your perspectives in the comments section. I'd really welcome them. And speaking of vigilance, it leads to a pressing question. If a deadly comet were barreling toward Earth with direct impact, something far more ominous than 3I Atlas safe paths, would the government tell us? NASA's policy outlined in directives like NPD 874 ʻOumuamua mandates timely and accurate reporting of any close approaches or predicted impacts from near Earth objects. They've committed to transparency through the Planetary Defense Coordination Office, sharing data openly to build public trust, enable global response plans. In practice, for low probability threats like the 2024 asteroid YR4, which had a slim chance of grazing us, NASA disclosed it promptly to astronomers worldwide. No cover ups in the cards. Secrecy would only sow chaos. And with international treaties like the UN's asteroid deflection protocols, hiding it would be logistically impossible anyway. Still, in a world of conspiracy whispers, it's comforting to know that our watchdogs prioritize candor over panic. Transitioning to its appearance, the imagery proves captivating. NASA's Hubble Space Telescope imaged it on July 21st at 277 million miles distance, revealing a teardrop dust envelope encasing a solid nucleus. Dimensions vary in estimates, 440 meters to 5.6 kilometers diameter, converging below 1 kilometer. Larger than Borsov's approximate kilometer scale, yet diminutive versus solar system behemoths like Hale-Bopp. Its form appears elongated, with a 16.16-hour rotation period deduced from brightness fluctuations. The coma, a nebulous envelope, extends 26,400 by 24,700 kilometers, expanding via solar-induced ice vaporation. A reddish tone derives from organic dust, with spectra lacking distinct lines, possibly indicating coarse or atypical particles. As the comet gets closer to the sun, it starts acting up more. Dust shoots out from it at a rate of 60 to 60 pounds per second. That's like tossing out a bunch of heavy backpacks nonstop. Gases come off even faster, 129 pounds per second of carbon dioxide and about 13 pounds per second of water vapor. This creates a spray of stuff pointing towards the sun and a long tail stretching away from it, which is just classic comet behavior. NASA's Hubble telescope recently gave us a better idea of its size, and that has a scientist named Avi Loeb saying it might force us to rethink everything we thought we knew. It makes you wonder what hidden surprises are lurking inside that dusty cloud around it. These outbursts aren't random. They're the comet's way of shedding its ancient skin, revealing layers frozen since the galaxy's youth and painting a vivid picture of solar heating in action. Delving into its composition and dynamics yields profound revelations. Looking deeper into what the comet is made of and how it moves gives us some really amazing insights. Comets serve as primordial archives, preserving data on the stellar and planetary genesis. Comets are like time capsules from the early universe, holding clues about how stars and planets first formed. Solar radiation induces sublimation, yielding the coma and tail. When the sunlight hits the comet, it makes the ice inside turn straight into gas without melting. That's called sublimation, and that's what creates the fuzzy cloud around it, the coma, and its tail. Spectropsy dissects emissions. James Webb's August 6th scrutiny identifies dominant carbon dioxide along water, ice, and vapor, carbon monoxide, and carbonyl sulfide, a prebiotic precursor. Scientists use a tool called spectropsy to study the light coming from it, like breaking it into colors to see what's there. On August 6th, the James Webb Telescope found that the carbon dioxide is the main gas, along with some water and ice water, gas, carbon monoxide, and carbonyl sulfide, a chemical that could be an early building block for life. Cyanide and nickel vapors appear, eroding the nucleus. They also spotted cyanide and nickel gases, which come from the comet's rocky core slowly breaking down. Spherex's August 7th 15 infrared survey seeks sulfur correlations to nascent disks. There's a lot of study going on with many telescopes. The carbon dioxide preponderance over water implies frigid origins, 50 to 100 Kelvin in an oxygen scarce outer disk. The fact that there's way more carbon dioxide than water suggests the comet formed in a super cold place around 50 to 100 degrees above absolute zero. That's like minus 369 to minus 279 degrees Fahrenheit in the far out part of its original star system, where there wasn't much oxygen to make water. Interstellar ultraviolet irradiation depleted certain carbon species, enhancing cyanide while diminishing others. Over its long trip through space, ultraviolet light from stars zaps some of the carbon stuff, boosting the cyanide signals while weakening others. Gemini South's August 27 spectrum aligns dust and ice with indigenous comets, implying galactic universality. On August 27th, the Gemini South telescope saw that the dust and ice in it looked a lot like comets from our own solar system, which means the way these things form might be the same all across the galaxy. Dust comprises micron to centimeter grains, reddened by the Thalin organics. The dust is made of tiny bits of micron size, thinner than a hair, up to the centimeter sized chunks like a small pebble, and it's got a reddish color from the complex organic goo called tholins. Emissions exhibits asymmetry, potentially from rotational venting. The way the dust and gas spray out isn't even. It fans out unevenly, maybe because of the vents on the comet tied to how it spins. Amino acids remain undetected, pending James Webb's November analysis. We haven't found amino acids yet. And amino acids, of course, are the basic parts of proteins that life needs. But we're waiting on more James Webb data coming this November. As a vestige of cosmic noon, it validates protoplanetary models. This comet is like a leftover from cosmic noon, a time about 10 billion years ago when stars were being born everywhere, and it helps prove our ideas about how baby planets form. Chemical congruence with Earth bolsters panspermia, the interstellar dissemination of light's precursors. The chemicals matching up with the stuff on Earth supports the panspermia idea that seeds of life can hitch a ride between stars on comets like this. Does one ponder terrestrial biology's extraterrestrial genesis aboard such an entity? It evokes profound reflection. Ever wonder if the stuff that makes life on our planet started its journey on something like 3I Atlas? It's a mind-blowing thought, one that bridges the gap between astronomy and the very essence of existence, suggesting we're all stardust with a twist of interstellar wanderlust. Regarding the tail, it constitutes the spectacle's pinnacle, the comet's celestial inscription. Now about the tail, it's the best part of the show, like the comet's signature painted across the sky. Diverging from the tail, less ʻOumuamua, I always have difficulty with that. 3I Atlas exhibits a pronounced one. Anti-solar dust and solar wind deflected on eon components. Unlike ʻOumuamua, which had no tail at all, 3I's Atlas had a big, clear one, a dust stream pointing away from the sun, plus a fainter ion tail that's pushed around by the solar wind. And the solar wind, they're just charged particles from the sun. Gemini's September 4th capture depicts it spanning 120th of a degree, 30 arc seconds, tadpole form with a bluish scattering. On September 4th, Gemini caught a picture of it, stretching about 120th of a degree across the sky. That's roughly 30 arc seconds, or the width of a pencil tip held at arm's length, looking like a tadpole with a blue tint from how light bounces off it. Inside the tail, there's a wild mix of rocky dust made from minerals called silicates, squishy organic stuff like carbon-based goo, bits of ice, and gases such as carbon dioxide, water vapor, cyanide, and carbon monoxide. Scientists measured all this using NASA's SWIFT telescope, which looks at invisible ultraviolet light, and SOHO's special camera that blocks out the sun's glare to watch the tail clearly. At its busiest, the tail blasts out up to 135 kilograms. That's about 300 pounds of gas every second. Like, I don't know, emptying a bunch of heavy trash bags nonstop. That cool blue color, it comes from super tiny dust specks bouncing blue light our way, or from carbon bits glowing like neon signs. And here's the fun part. On September 4th, regular stargazers with backyard telescopes snapped super clear pictures of it, proving anyone can jump into real science and help discover cool space stuff. Any weird stuff? Some people on social media are buzzing about strange signals or a mysterious glow on the front of the comet. But it's nothing spooky. It's just the dust particles scattering light forward. Kind of like how fog makes car headlights look brighter. The Mars Reconnaissance Orbiter is zooming super close on October 3rd to map out all the chemicals in the tail. And Europe's JUICE spacecraft will watch how the tail twists and turns during its flyby near Jupiter. Basically, the tail acts like a rolling science lab. It carries special fingerprints of atoms, called isotopes, from the comet's home star far away. And by tracking how its light dims and brightens over time, we can uncover tons of hidden secrets about what's inside. If scientists spot things like polycyclic aromatic hydrocarbons, think fancy loops of carbon atoms, it might mean that the comet started out in a nice warm zone around its original star where water could stay liquid and maybe even kickstart life. This isn't just cool to stare at. It's like a storyteller that shifts with every nudge from the sun, dropping clues that could one day help us find planets buzzing with alien possibilities. Controversy enlivens the discourse. The debate around this comet really spices things up. A.V. Loeb's August 23rd essay queries, ought we prefer commentary status? In an essay from August 23rd, Harvard scientist A.V. Loeb asks, should we hope it's just a regular comet? Affirmative for security, yet intellectual openness essential. He says yes, because that would mean it's safe and not a threat. But we still need to keep our minds open to the wild ideas. Extraterrestrial advocates cite delayed tail emergence post-July, elliptic precision, 1% natural, substantial dimensions, uncommon for ejecta, and navigational finesse. People who think it might be from aliens point to a few strange clues. The tail didn't show up until after July, even though the comet was close enough to the sun to start acting up sooner. Its path lines up almost perfectly with our solar system's plane, which has only a 1 in 100 chance of happening naturally. It's bigger than most chunks, kicked out from other star systems. And it seems to weave through our planets with sneaky precision. His July 17th modeling posits low thrust propulsion. In a paper from July 17th, Loeb even ran computer models showing how it could be powered by tiny engines for gentle steering. He posted this on YouTube, saying it's totally possible. Echoing such intrigue, author in space anomaly research, Mike Barra, in a recent podcast appearance, grapples with the object's peculiarities, declaring it too weird to dismiss outright as a mere comet. He's oscillating between notions of an alien spaceship, a chunk of cosmic debris, or even a remnant from an exploded planet, perhaps one that once orbited near Mars or in the asteroid belt, shattered eons ago by some cataclysmic force, natural or otherwise. Barra draws stark parallels to the 1997 comet Hale-Bopp, which he has long suspected of artificial redirection, suggesting that 3I Atlas's orbit mirrors it suspiciously. It's almost like somebody redirected this thing. He questions the delayed coma development, arguing it defies the traditional dirty snowball comet model, as activity should have surged early if purely natural. The close Mars flyby strikes him as too coincidental, fueling speculation of deliberate nudges, be it by extraterrestrials with rudimentary flying saucer tech, or covert human efforts to orchestrate a spectacle. Ultimately, Barra leans towards intelligence at play. He says, either it is a product of some intelligence beyond Earth, or it's something that we did. His views, steeped in theories of ancient cosmic upheavals, amplify the debate without conclusive claims. But it's inviting listeners to probe beyond official explanations. Whether Loeb's models or Barra's bold strokes hold water, they remind us that science thrives on the edge of the unknown, turning a simple flyby into a mirror for our deepest curiosities about who's out there and what they're sending our way. Conversely, NASA affirms commentary hallmarks: gaseous effluence, tail elaboration. On the other hand, NASA scientists say it's behaving exactly like a regular comet, with gas pouring out and the tail getting longer and more detailed. Carbon dioxide and water refute chemical voids. The discovery of carbon dioxide and water vapor proves there's no shortage of chemicals inside, which shuts down ideas that it's just an empty rock or something weird like that. Northeastern's expert concurs. Likely natural, an expert from Northeastern University agrees, saying, quote, probably just a natural comet. Reddit attributes image artifacts to instrumentation. On Reddit, people explain away blurry spots in photos as glitches from the cameras or telescopes. Loeb advocates inexpensive interceptors, 10 million apiece, for single detection. Detractors decry sensationalism. A.V. Loeb pushes for cheap space probes, about 10 million each, to fly close and check for any radio signals or other signs. But his critics call it over-the-top hype and attention-grabbing. Scientific consensus favors natural origin, though speculative media like sci-fi entertains alternatives. Oh, we all love sci-fi. Most scientists agree it's a regular comet, though TV shows like the ones on Sci-Fi love to play with the what if it's aliens ideas. Such dialogue fosters imagination. In expansive cosmos, Vigilance merits consideration. All this back and forth talk gets our imaginations going. In a universe this huge, this expansive, it's smart to stay watchful and curious. It sparks classroom debates, late night ponderings, and perhaps even inspires the next generation of stargazers to build better telescopes or to dream up deflection technology. Because if 3i Atlas teaches us anything, it's that the stars aren't just about us, they're full of stories waiting to be told. We owe a huge shout out to all the telescopes and technology and that industry and space machines teaming up like a super squad to check out this comet. It's like a global band jamming together. Hit the perfect notes. Hubble's photos from August 7th sharpened our guess on the comet's size, making everything fit better. James Webb spotted the very first hints of the chemical called carbonyl sulfide from something outside our solar system. Super exciting, like finding a rare ingredient in an alien recipe. The Mars rovers, tough little guys like Perseverance and Curiosity, will click pictures during the comet's super close zip on October 3rd. And the Mars Reconnaissance Orbiter will dive deep into the tail's makeup with its fancy camera and other NASA adventures. Europa, Clipper, scouting icy moons, Lucy hopping asteroids, and Psyche digging into the metal worlds. Throw in views from all angles, while the brave Parker Solar Probe might sneak a peek if the stars align just right. It's the one that high dives towards the sun without melting. From Europe, SOHO keeps tabs on the glowing charged particles, and the JUICE probe will eye how the tail dances during its Jupiter flyby. Down on Earth, the Gemini telescope watches the tail stretch and grow night after night. And cool tools like iTelescope let everyone and everyday stargazers rent time on ProGear to snap their own shots. This worldwide crew isn't just snapping selfies with space. It's proof of how smart humans are, linking brain power from Hawaiian peaks to dusty Mars craters, leaving no stone unturned and catching every tiny light speck to crack the comet's big mysteries. New data is pouring in super fast right now. Scientists are studying things like uneven glowing from cyanide, that's a gas in the tail that shines brighter on one side, and how the dust fans out like a messy spray from a hose. By December, when the comet starts fading into the distance, we'll have a massive pile of info to sift through. Tons of light patterns called spectra, photos, and computer drawings that could keep college students busy writing big papers for years and years. Looking ahead, after the comet's super close swing by the sun on October 29th, it'll quiet down and then show again in December skies. But it'll look dimmer and smaller as it zooms away. We can't scoop up a real piece of it because it's racing too speedy, over 30 kilometers per second. So instead, we'll use cool computer programs and technology, telescopes, to imagine flying right next to it, like a video game. This whole adventure is helping us update how often these space travelers pop by, maybe every 10 years that we can actually spot with our telescopes. For people hunting clues about life on other worlds, the sulfur hints in the comet point to chemical tricks that might happen on far-off planets, like recycling loops that build simple life stuff. Avi Loeb's big idea for constant sky watching robots is getting politicians in Washington talking about money. Who wouldn't want a network of cheap space guards? As the comet waves goodbye, it leaves us with huge questions. How many more like it are drifting out there? What wild tales will they bring next? Soft hints of space chemistry or scary warnings carved like fire in the dark? To wrap it all up, 3I A Atlas is like the ultimate comet, a big frozen snowball from space that wakes up near our sun, spraying a shiny tail across the sky like cosmic fireworks show. It's weirdly familiar, made up of stuff like the comets we know, but totally from another star system, like a stranger who feels like an old friend. Science helps us see way back in time through its clues. The tale spills the beans on what's been built from out there in the universe. And the crazy, what if it's aliens, ideas makes us dream even bigger about what's possible. Just 3 visitors like this have swung by our skies so far, which is an awesome gift from the universe packed with 2 trillion galaxies. Keep watching the stars. Who knows? The next one might flip everything we think we know upside down. Thank you very much for listening. And don't forget, please like and subscribe and content. Until the next time, goodbye, everyone.